Welcome! So in this video we are going to discuss why we add fractions the way we do. The motivation for this video is my observation that a lot of times students struggle with adding fractions, especially if those fractions are rational expressions. So this video is meant to clarify why is it that we add fractions the way we do, by using some examples from the real life. So let us begin with discussing the following example. So suppose that we have a cake, and the cake is cut into three equal slices, and so each slice of the cake is 1/3 of the whole cake. So now the question is, what portion of the cake is the shaded area? So the shaded portion of the cake consists of two slices, and each slice is 1/3 of the cake. So these two slices of the cake taken together are going to be 1/3 of a cake plus another 1/3 of the cake. So it's going to be 2 of the 1/3 of the cake. In this case, we say that this shaded portion of the cake is 2/3 of the cake. So this is just to clarify what we mean by 1/3, what we mean by 2/3. So in general, if we have a over n plus b over n, this is going to be a times 1 over n plus b times 1 over n. So this is going to be a plus b times 1 over n, which is a plus b over n. So if we have two fractions such that their denominators are equal, to add these two fractions, all we have to do is just to add their numerators, and the denominator stays the same. So for example, if we want to add 1/5 plus 2/5, this is going to be 3/5. And just to kind of convince ourselves that this is still going to work with the cake example, so if we have the cake divided into 5 equal slices, so let me see if I can even figure out how to do that, 5 equal slices. So it's just going to be something like this, more or less. Okay, so if we take 1/5 of the cake and add to that 2/5 of the cake, then in this shaded area we actually have 3 of these slices, so we are going to get 3/5. So our algorithm actually works, and so we use this formula to add fractions such that their denominators are equal. So let's just do another example just to make sure we've got this. So suppose we have 1/7 plus 3/7. This is going to be 4/7. So now the question is, how do we add fractions whose denominators are not equal? So to answer this question, let us consider this example. Let us try to figure out what is 1/4 plus 1/3. So let's just think about two cakes. So here we have a cake is cut into 4 equal slices, and the other cake is cut into 3 equal slices. And what we are trying to figure out is what portion of one cake are we going to get if we take this slice, 1/4 of a cake, and put it next to a slice that is 1/3 of a cake. So if we put these two slices that are shaded in green color together, what portion of a cake is that gonna be? So the difficulty of this example compared to the previous example is that the first cake is cut into 4 equal slices, and the second cake is cut into 3 equal slices. So it would be nice if each cake was cut into the same number of slices. So try to cut each cake into the same number of equal slices. So you can try to think about how this can be accomplished. I'm gonna propose the following solution here. So for the first cake, so this is my first cake, I'm going to take each slice that I already have in the cake and cut it into 3 equal sub-slices. So I take each slice and cut that each slice into 3 equal sub-slices. So I had 4 slices to begin with, and then each one of those 4 slices was cut into 3 additional slices. So I get a total of 12 equal slices. For the second cake, I'm going to take each one of the 3 slices that I already have, and I'm going to cut each one of those slices into 4 sub-slices. Okay, so again, I had 3 slices to begin with, and then each one of those 3 slices was cut into 4 additional slices. So I get 12 equal slices. So now we can see that 1/4 of a cake, of the first cake, is actually the same as 3 of 1/12 of a cake, right? So 1/4 of a cake is 3 of these smaller slices, and each one of these smaller slices is 1/12 of a cake. And on the other hand, 1/3 of a cake is equal to 4 of these smaller slices. So 1/3 of a cake is equal to 4 of these smaller slices. So it's 4 times 1/12. And so then now it's clear that if we would put these 2 slices together, so if I would take 1/4 of a cake, which is 3/12 of a cake, and if right next to it I would put 1/3 of a cake, which is 4/12 of a cake, so this would be 1/3 of a cake, which is 4/12 of a cake, I'm going to get how many 12ths of a cake? Let me count. 1, 2, 3, 4, 5, 6, 7. So 1/4 plus 1/3 is 7/12. Okay, so in this example we figured out how to add 1/4 to 1/3, and it is actually 7/12. Now the next question that we want to ask for this example is how could we figure out that 1/4 plus 1/3 is 7/12 without drawing cakes? So in order to figure out how to add 1/4 and 1/3 without drawing cakes, first we need to understand why is it that the number 12 appeared in our reasoning before. So it turns out that number 12 has both 3 and 4 as a factor. So number 12 has both 3 and 4 as a factor. It is also worthwhile noticing that the number 12 is the smallest number that has both 3 and 4 as a factor. So number 12 is the smallest such number. Another observation that we make here is that 1/4, we said that it is equal to 3/12. So, but 3/12 is 1/4 times 3/3. And notice that 3/3, well, that's going to be 1, because if you take a cake, you take 1/3 of a cake plus another 1/3 of a cake plus another 1/3 of a cake. If you add this together, you're just going to get 1. And we know that if we multiply something by 1, we don't change anything. So 1/4 times 3/3 is the same as 1/4. And then we can multiply 1/4 by 3/3, and we get 3/12. So this is how we could figure out this without drawing a cake. And so then similarly, 1/3 is 1/3 times 4/4, which is 1 times 4 over 3 times 4, which is 4 over 12. And so finally, when we have 1/3 plus 1/4, we can write it as 1/3 times 4/4 plus 1/4 times 3/3. So this is going to be 4/12 plus 3/12. And now by the previous rule, if we have two fractions such that their denominators are equal, so both denominators here are 12, we can add these two fractions by just adding their numerators. So we have 4 plus 3 over 12, which is 7 over 12. Okay, so this is how we can add 1/3 plus 1/4 without drawing cakes. So let us now consider another example. Let us try to add 1/2 plus 1/3. And this time we are going to do this without drawing cakes. So we are going to do this in steps. So step 1 is going to find the least common multiple of 2 and 3. So least common multiple of 2 and 3. So the least common multiple of 2 and 3 is the smallest integer that contains both 2 and 3 and as a factor, that contains both 2 and 3 as factors. So if we think about it, actually 6 is such a number. So 6 is the least common multiple of 2 and 3. Because 6 is 2 times 3. So now in step 2, we want to rewrite each fraction so we have 6 in the denominator. So what do we need to multiply 2 by to get 6? We want to have 6 in the denominator. Well, we need to multiply 2 by 3. So it means that we are going to multiply 1/2 by 3/3, which is 1. And it's important that we are multiplying by 1, because if we multiplied 1/2 by anything other than 1, we would change the value of 1/2. So in the end, we are going to get that 1/2 is 3/6. On the other hand, 1/3, how many 6ths would that be? Well, 1/3 can be multiplied by 2/2, so this is going to be 2/6. And then on step 3, we add the two fractions using their representations from step 2, using their representations from step 2. So 1/2 plus 1/3 is actually 3/6 plus 2/6. So this is 5/6. And 5/6 is the answer to our question. So now let us consider a shortcut. So we do not have to write these 3 steps each time we add these 2 fractions. So we could just say that 1/2 plus 1/3. So we could just realize that the least common multiple of 2 and 3 is 6. And then we would realize that in order to get 6, we would need to multiply 2 by 3. So we would multiply 1/2 by 3/3. And in order to get 6, we would need to multiply 3 by 2. So we would multiply 1/3 by 2/2. And so in the end, we would get 1 times 3 plus 1 times 2 in the numerator, which is 5. So in the end, we would get 5/6. So let's just do another example. Let us add 1/5 plus 1/4. So the least common multiple of 5 and 4 is 20. In order to get 20, we need to multiply 5 by 4. So we multiply this fraction by 4/4. And for the other fraction, we need to multiply it by 5/5. So in the end, in the numerator, we get 4 plus 5. So in the end, we get 9/20. One more example. So let's try to add 1/6 plus 1/3. So this one is interesting because if we multiply 6 times 3, we get 18. And 18 is certainly a number that has both 6 and 3 as a factor. However, if we write 6, 6 is 2 times 3, and it's also 6 times 1. So 6 has a 6 as a factor, and it has a 3 as a factor. And 6 is smaller than 18. So actually, the least common multiple of 6 and 3 is not 18, it is 6. So we are going to have 6 in the denominator. So 1/6 already has 6 in the denominator. So as far as this fraction is concerned, we don't multiply it by anything. However, we need to multiply 1/3 by 2/2 to make sure that it has 6 in the denominator. So in the end, in the numerator, in the answer, we have 1 plus 2. So this is 3/6. Now 3/6 is 3/3 times 2. So this is 3/3 times 1/2. However, 3/3 is equal to 1. So in the end, the answer is just 1/2. So the answer is just 1/2. So let's do one more example like this. So let's add 1/4 plus 1/2. So the least common multiple of 4 and 2 is just 4, because 4 is 4 times 1, and it is also 2 times 2. So 4 has a 4 as a factor and also a 2 as a factor. So our common denominator is going to be 4. And for the first fraction, we do not need to multiply it by anything. However, for the second fraction, we need to multiply it by 2/2. So then in the answer in the denominator, in the numerator, we are going to get 1 plus 2. So in the end, the answer is 3/4. I hope you liked this video. If this video helped you to understand better why we add fractions the way we do, and to clarify the algorithm for adding fractions, and remind you how to add fractions in such a way that you will not forget in the future and will understand it better, that's great. If you found this video helpful, please subscribe. Please put a like. This way you will help YouTube to promote these videos, so other people will be able to see them as well. And you will also be supporting my work on these videos. I would love to hear from you in the comment section if you have any questions or if you have any suggestions for future videos.